Hey everyone, my name is Alec. I'm the founder of OpenClass, and I want to record a quick video here walking through what OpenClass assignments look like for students and why I'm especially excited about the implications that these assignments can have in coding classes, computer science classes, data science classes, where as somebody with a computer science background, I can speak on my experience that most of my classes have been of the structure where there's your lecture, then you have big programming projects and tests, and that's pretty much it. But sort of the problem with that is there's nothing sort of like a more low stakes way to practice concepts that are really important, where a lot of students are going to struggle with these projects because that's too big of a high pressure, high stakes setting to practice more core fundamentals. Students get stuck early, aren't able to figure it out, and it's tough for them to move on. So in my opinion, this is something that's been really lacking from coding classes, is just a lower stakes way to practice the fundamentals. And so I'm going to show you what this looks like for a student. So OpenClass integrates with D2L and with Canvas. You could also use this outside of a learning management system, but basically as soon as an instructor you publish your assignment, students will be notified from D2L or Canvas and also via email. They'll receive a link which will take them to the assignment overview page, which looks something like this. Students can click this begin assignment button and they'll be taken to your first question. So here's what a coding question looks like in OpenClass. There's your title, any more information that comes with the question, and basically just a text editor here where students are left with whatever starting code you wanted to leave them with. So this is just an example question I wrote. Write a function that sets a value in a NumPy array. Students are given basically the skeleton of the function. They just have to enter their code here. There's a little note that the instructor left. So a student could say, okay, let's set this value. So a ind equals val, something like that. A student can test their code before they submit it. So if they want to include test cases, they could see, okay, what does this function take in? So the first value is a NumPy array, how long it is, so 5, let's say 3, 11. You can run your test case. Okay, there's my output. Yeah, this looks like it's doing about what the function is doing. If there's a hint that's included with the question, that'll also be shown here. So, students can get this practice. Once they're comfortable with their solution, they're able to submit code and continue. As soon as they do that, their code, the output from their code is compared to the output from the instructor's solution code against whatever test cases the instructor left. So for this example, I got it correct. It says you passed all the test cases. You can see here's all the test cases that the instructor left. Boom, my output matches the instructor output. Great, I got this correct. If I'm at all still confused about this concept, it also shows me the instructor's solution. Let's say I didn't get this question correct, I can sort of compare my answer to what the instructor said and be like, oh, this is how you set a value in a NumPy array or whatever the question is. Also associated with each question are any of the targeted resources that were discussed in class. So for example, this could be a presentation slide that talks about NumPy or whatever. It could be lecture clips, YouTube clips, textbook slide or textbook pages, whatever type of resources that there were that are specifically associated with whatever the concept is. So for this example, NumPy arrays, here's this little YouTube video. So the point is the student doesn't just see the answer, but they can also see the feedback pertaining to how that answer is derived and be able to connect it back to class to just help them retain that information and be able to learn from this concept. So they can go through this feedback, and then every question concludes with a multiple choice, what's called a mastery question, where basically the key point of this is to make this feedback more interactive, more engaging, so students actually have to go through it, understand it, and then sort of apply that they've understood this. So for this example, it's saying, okay, what's the output for this specific input? The student can go through and say, okay, setting index 0 to value 15, which one of these? That looks like it's this one. Boom, got it correct. If you get the answer correct or incorrect, there may be a reason behind this is why the answer is correct, this is why it's incorrect, which will also be displayed as you're getting questions correct. This is for both the coding questions and these multiple choice questions. This mastery progress bar will increase, and assignments will basically continue drawing questions from the instructor's question pool until the student achieves 100% mastery. So what's cool about that is if a student really understands these concepts, it's not just going to drill it to death for them. It's going to say, okay, you've proved you've mastered this after 4 or 5 questions, like you don't need any more practice. But the other students that are struggling more with the foundational concepts are going to be able to continue to receive more practice and sort of get them up to par with the rest of the class at their own pace. So that's what a coding question looks like. The other cool thing with this is as you continue the assignment, you're able to mix and match both coding questions and conceptual questions, again, in this very low stakes format. So here's a question: what's the cosine similarity between this array and this array? So students can think about this question. If they have like a pen and paper, they could do whatever work on the side. These aren't timed. These are, again, low pressure, low stakes, low stress. Student can enter their response in here. So whatever, after they do this, they could say, okay, I think the answer is 0.5 or whatever it is, save the response and continue. And then they'll be shown a similar feedback page to the coding questions. Obviously for conceptual questions, it's not testing their output with anything, but they're able to see, okay, here's the instructor solution. Here are these, whatever feedback's associated with this. And then here's the multiple choice question. So it follows that same format. And that's what instructors are building in OpenClass. I'm really excited about the implications that these can have in coding classes, computer science classes, data science classes, computational physics classes, whatever. And yeah, if you're an instructor and you're interested in bringing this to your class, please check out openclass.ai. It's free to get started. Right now, we're just seeking early adopters, people interested in sort of embracing these modern teaching techniques and bringing this really cool thing to their coding classes. Or you can also feel free to reach out to me directly. My email is alec@openclass.ai. If you have any questions, concerns, things like that, if you want to set up a Zoom demo or need more information, need help getting started, I'm here in any capacity that you need to help you sort of figure the system out. I hope this is something that's really able to help your classes. This is something that I know as a student I would have loved to receive this additional practice, whether it's an intro to data science class and sort of like an early on class where students may just need help figuring out how to code it in general, intro to programming, whatever, or even if it's a grad level class. I think it's still important that students understand how to do these concepts in a more low stakes manner. So I really think that this could fit with a lot of class types. But yeah, thank you for watching this. Hopefully this is something that'll be able to fit in your class, and thank you.